Welcome to AI Lab Headquarters, where we break down tech so you don't have to. Last week, I spent 5 hours and $49 completing Google's latest AI Essentials course for beginners. And since I need to recoup that money to fund my addiction to parasocial relationships with AI, I made this video to share 5 key takeaways from the course, the pros and cons, and to give you the definitive answer to the burning question. Will the certificate you receive at the end get you laid? I mean, paid. Paid more. Because you now have a new skill. That was a weird slip of the tongue. Moving on. If you don't have a technical background but still want to learn the basics of artificial intelligence, stick around. We're distilling Google's 4-hour AI course into just 10 minutes. I'll admit, I was skeptical at first. I thought the course would be too conceptual. And we're all about practical tips here. Plus, knowing Google, I figured the course might disappear after an hour. But to my surprise, the underlying concepts actually made me better at using tools like ChatGPT and Google Bard, and cleared up a bunch of misconceptions I didn't even know I had about AI, machine learning, and large language models. Starting with the broadest possible question: what is artificial intelligence? I'm almost embarrassed to admit this, but I didn't realize AI is an entire field of study, like physics. And much like physics has subfields like thermodynamics, AI has subfields like machine learning. Going one level deeper, deep learning is a subset of machine learning. And deep learning itself can be broken down further into discriminative models and generative models. Where do large language models, or LLMs, fit into this? They're part of deep learning, sitting right at the intersection of generative models and deep learning. This is the technology powering the apps we all know and love: ChatGPT, Google Bard, Midjourney, and more. Let me know in the comments if this was news to you too. Machine learning, as it turns out, is pretty straightforward. It's a program that uses input data to train a model. Once trained, that model can make predictions based on new, unseen data. For example, imagine you train a model on Nike sales data. That model could then predict how well a new Adidas shoe would sell based on Adidas sales data. There are 2 main types of machine learning models: supervised and unsupervised learning models. The key difference? Supervised models use labeled data, while unsupervised models use unlabeled data. Here's an example of supervised learning. Let's say you have historical data that shows the total bill amount at a restaurant and the corresponding tip amount. In this case, the data is labeled. Blue dots mean the order was picked up, and yellow dots mean it was delivered. A supervised learning model could predict the tip amount for the next order based on whether it's picked up or delivered. Now for unsupervised learning. This type of model looks at raw data and finds natural groupings. For instance, imagine plotting employee tenure against income. Without any labels, an unsupervised model might find clusters, like employees with high income to years worked ratios versus those with low ratios. Here's a pro tip. After a supervised learning model makes a prediction, it compares that prediction to the training data and adjusts to close the gap. Unsupervised learning models don't do this, which is why they're better for exploring patterns in raw data. Deep learning is essentially a type of machine learning that uses artificial neural networks. These are inspired by the human brain and look like layers of interconnected nodes or neurons. The more layers a model has, the more powerful it is. Deep learning also enables something called semi-supervised learning. This is where a model is trained on a small amount of labeled data and a large amount of unlabeled data. For example, a bank might tag 5% of transactions as fraudulent or not fraudulent, and leave the other 95% unlabeled. The deep learning model uses the 5% to learn the basics and applies that knowledge to the unlabeled data, creating an aggregate dataset for future predictions. Deep learning can be further divided into 2 categories: discriminative and generative models. Discriminative models classify data points. For example, if you have labeled pictures of cats and dogs, a discriminative model can predict whether a new picture is a cat or a dog. Generative models, on the other hand, analyze patterns in the training data to generate something entirely new. For instance, a generative model trained on images of dogs could create a completely new image of a dog. Here's an easy way to tell the difference. If the output is a number, a classification, like spam or not spam, or a probability, it's not generative AI. If the output is text, speech, images, or audio, it's generative AI. LLMs, like ChatGPT and Google Bard, are subsets of deep learning. And while they overlap with generative AI, they're not the same thing. LLMs are typically pre-trained on massive datasets to handle common language tasks like text classification, question answering, summarization, and generation. Once pre-trained, they're fine-tuned for specific industries or tasks. Here's an analogy. Imagine you have a dog that's been trained with basic commands like sit and stay. That's pre-training. If that dog then becomes a guide dog or a police dog, it undergoes specialized training. This is fine-tuning. In the real world, a hospital might use a pre-trained LLM and fine-tune it with medical data to improve diagnostic accuracy. This is a win-win because large companies develop the general-purpose LLMs, and smaller institutions fine-tune them with their domain-specific datasets. One of the most practical takeaways from the course was about writing better prompts. The secret? Surface the implied context. Let's say you're asking an AI tool for restaurant recommendations. If your friend is vegetarian, you automatically suggest vegetarian-friendly options, even if they don't explicitly say so. AI tools, however, need you to spell out that context. For example, instead of saying, "Help me negotiate a raise," say, "I got a 10% raise last year. I'm the highest performer on my team, and the industry average is 12%. Help me negotiate a 15% raise." The more context you provide, the better the output. For complex tasks, break them into smaller steps. This is called chain of thought prompting. For instance, instead of asking a chatbot to write an entire cover letter, start with, "Based on my resume and the job description, write an attention-grabbing opening paragraph." Once you have the intro, tweak it and ask for the next section. Rinse and repeat. This approach works for anything from marketing plans to vacation itineraries. Before we wrap up, let's talk about the limitations of AI. First, there's biased data. If the training data is biased, the AI will reflect those biases. Second, many AI models have cutoff dates for their training data. If you ask about recent events, the output might be inaccurate. Third, hallucinations. AI can sometimes generate factually incorrect information, especially for high-stakes tasks like medical advice. Always double-check. So, is Google's AI Essentials course worth it? If you're a beginner or visual learner, absolutely. The course is structured, easy to follow, and the certificate is a nice bonus for your resume or LinkedIn. But if you're already using tools like ChatGPT and Google Bard, the course might feel a bit too basic. Pro tip: you can access this course for free by enrolling in Google's Project Management certification on Coursera. See link below. If you found this video helpful, check out my summary of Google's free AI course for even more insights. As always, have a great one. And remember, the only thing scarier than AI taking over the world is you not keeping up with it.